In this video, I'm going to do a calibration on a Philips reel-to-reel. It's an N4504. It was brought to me by a client, and they already went through the main process of refurbishing this unit. They replaced all the caps in it and replaced the belts and brought it to me just to check the speed calibration and to check the bias. So that's what we're going to do now. I have here a Philips reel-to-reel deck. This was brought in to me by a client who has done a really good job. They've recapped it themselves, and she recapped everything, changed all the electrolytics on all the boards, cleaned up the board, and replaced all the belts. And also she replaced the grommets that hold the motor in place. These are what the original grommets looked like, telling me that she got them at Canadian Tire, but the original grommets, as you can see, were just completely falling apart. And she's got new grommets here. I'll show you a close-up of the motor here. So here are the new grommets, as you can see, nice and tight. She also replaced all the belts on it, replaced the capstan belt here, the counter belt over here, and the two reel drive belts on either side for take up and supply. So as you can see, the unit has plenty of torque for fast forward, for rewind. This is actually a very nice deck. It's a 3-head deck. And why it was brought to me is she wants the speed calibrated. Now this one uses a DC motor, so there's a 3-speed deck, 7.5, 3 3/4, and 1 7/8. I'm going to use my my DSO for this, I think. I've got a test tape that I've recorded. This is not a new tape, it's actually quite an old tape. It's an old tape from the 1970s, but it was one that hadn't been used. It was a brand new, out of the box tape. So what I've done is I've recorded a test tone on here, 1 kilohertz tone, to set the speed at 7.5 IPS. I use my Akai 4000, which is a AC motor driven capstan. So the speed on it is actually very good because the speed is synchronized from the AC line coming in. So the AC synchronized decks are actually quite accurate. And yes, I know people are going to say, oh, they can drift, and that is correct. If the run capacitor is getting weak, they can slow down a bit, but as long as the run capacitor for the motor is not bad, they generally do keep pretty good accurate speed. That is why they were used on turntables for many years before direct drive tables became a common device. Even for a lot of the belt drive, they would use an AC motor on them. As you can see, there's 4 wires to the motor. You've got your DC supply, and there's a feedback loop. So there's going to be a frequency generator in here of some type. Let's see if we can scope this thing and take a look at the frequency coming off of this motor. And there it is. Yeah, I'll show you the scope. So this provides a feedback loop, and there'll be 3 adjustments on the board here for the speed. Let's take a look at the scope here. So I haven't scoped it yet, but if I scope the motor, or scope the frequency generator, you'll see this one's at 755 or 760 hertz, looks like. And if I speed the motor up, if I can find the speed control here, now it's gone to 1.41 kilohertz, 1.48. That's the 3 3/4, and 2 kilohertz for the 7.5. So it is a feedback loop on this one. Okay, the 3 adjustments. I'll talk over this. Here's my 7.5 adjustment, so I'm going to adjust this so that the speed is exactly 1 kilohertz. There we go, 1 kilohertz. So we adjust that one. This is 7.5 IPS. We adjust that one with R69. Looking from the bottom, it's this one here. So we adjust our playback for 1 kilohertz. Now, there's a couple ways I can do it. I can switch the speed down and continue to play the 1 kilohertz tone and adjust our was R68 and R65 are the other two. So R68 is this one and R65 is that one. This is going to be a 1 kilohertz portion coming up now. So there's 1 kilohertz recorded at 3 3/4 IPS, which I've already set the speed, as you can see, so I'm just verifying it that it is accurate. So there we have 1 kilohertz playing at 3 3/4 IPS. But I could have done it, if I go back to the other portion, it would play it at 500 hertz. Right, and here we are, 500 hertz, if you can see that. 500.46. Whoops. So this should get me to there's the 1 kilohertz portion there. And for the 1 7/8, if I play back the one kilohertz portion at 1 7/8, this is the 7.5 recorded, I should be able to set the speed for this one for 250 hertz. So now we're playing back 250 hertz, just about. There we go. Off this portion of the tape, if I go to the next portion of the tape, this would play at about 500 hertz. Yeah, which it is, because that's the 3 3/4 inch recording of 1 kilohertz. And if I go to the next segment of the tape, we have 1 kilohertz right there. So our speed is now calibrated for all 3 speeds. Now the client wants me to check the bias, and to do that I need to hook up my function generator and put a tone in and set the bias levels. While I'm at it, I'm going to give the switches a shot of deoxit just to make sure that they're clean. We'll also give the controls a clean, if I can get in here. Looks like these controls actually have a piece of tape over them to keep them clean, to keep the dust out of them. Remove that in order to get the nozzle in here and get some cleaner into these controls. We'll do the same for the other controls. We'll just lift up the tape here so that I can get into the side of the control. Give it a shot of cleaner, both sides. So what they did is they stuck masking tape over top of the controls. I guess this is an attempt to keep dust from getting into them, which is a good idea. It keeps the dust out, but if you try to get in there to clean them, you gotta open it up so that you can actually get your nozzle in there and get some cleaner delivered. Okay, I believe I figured out what these controls are. This is the record level. This is the record balance, because if I turn it to the left, I have meter here. Turn it to the right. So that's my balance. So that should be about set in about the middle, I would think. So there's one extreme, there's the other, and that should be about right about the middle, should be right about there. Yeah, there's the middle right there. We have a sticking meter on this, so don't worry about that. We'll see if we can deal with that later. Anyway, we'll set the recording for, set it for 100%. And this is about a 400 hertz tone that's going in here now. Let's see how this thing works. The switches are as follows on this. Source and tape. This would be for left channel and right channel. Left channel, right channel, and stereo. This is the tape speed, and this one here is probably, I would think this was for the different type of tapes, normal and low noise tape, I would think. That's what that one is for. Let's hit the record button here. I'm in record mode, so let's hit pause, and we can see that our levels are coming back. Level's a little bit higher on the left channel. Let's take a look at the bias settings. To set the bias according to the manual, which is written in German, so I'm having to translate this, but we use test point number 7 here off the DIN plug and ground, and we set the bias voltage to 4 millivolts. There's 2 bias adjustments here. This is the one for this channel. My bias voltage is a little bit high here, so we're going to just drop it back down a bit. Try and get it down to 4 millivolts. Right here, that one and that one. So I'm just going to adjust my bias. I'll adjust it for one channel, and then I'll measure the voltage actually on the control. So now we can see our RMS is about 14 volts right off of the control. So I'm going to go to the other channel and we'll take a look at what it is. It's also a little bit high, so we're going to bring it down to about 14.4, the same as the other one was. Try and get them pretty close. So here's one channel, 14.46 at 94.5 kilohertz. And there's the other one. So now that I have my bias dialed in, so my course settings are fairly close, I'm going to do a test recording now, and I'm just listening to how the sound sounds. Because if your bias level is too low, your high frequencies will be overemphasized, and you'll end up with a fair bit of distortion. And if your bias signal is too high, your high frequencies will be attenuated. So what I'm doing now is I'm going to listen with headphones. This is playback from the tape monitor. I'm just going to take a listen to the levels and check the frequencies using my meter, and then I'm going to do some music recording on here. I don't know how the microphone's going to pick this up from my headphones, but as I sweep the frequency up, we're at about 9 kilohertz now. As you can see, about 12 kilohertz. As I continue to increase and get to the limit of the tape, we're well beyond what the tape can record now. I'm up at 30 kilohertz. Let's bring this thing back down here. And I'm now at 20 kilohertz. As you can see, the levels roll off when you get to the higher frequencies. If I change the tape speed, you notice that at the slower speeds, the frequencies drop off big time. Like I'm only at about just over 7 kilohertz now. As you can see, the roll off. If I go to the monitor, this is what's going in. Okay, I've got about 100%, but we've got nothing coming back, or virtually nothing coming back at 7 kilohertz for 1 7/8. As I drop the frequency, okay, I can start to hear it now. So it looks like we're going to roll off just before 7 kilohertz. I can hear it now. Here's 6 kilohertz, 5 kilohertz. We got to switch bands here. It's 500 hertz. Let's see where it rolls off here. So it's starting to roll off there, just over 2 kilohertz. 6 kilohertz. It's getting pretty weak. If I go to 3 3/4, okay, our frequency response comes back substantially there. If I go to 7.5, you can see the frequency response comes right up at 7.5. If I switch my band here, here's 6 kilohertz. Our levels coming back are pretty much the same. I'm not quite balanced here. Let me just adjust my balance control here. Okay, at 6 kilohertz, the what's coming back off tape is virtually the same as what's going in. If I go to 7 kilohertz, eight kilohertz, 10 kilohertz. We'll continue up 12. Now we're going to start to roll off here because we're now at 17 kilohertz, and yes, I expect that now we're at 20 kilohertz that it's going to be well beyond what the tape is capable of. In fact, I can hear the at 20 kilohertz I can hear in my headphones, I can hear the tone I'm recording beating with the bias oscillator. Don't hear anything at 20 kilohertz. My hearing isn't that good. I can't hear anything at 20 kilohertz. Actually, I'll tell you where I can hear it. Okay, I can hear it at 15. Just over 15 kilohertz. 16 kilohertz, I can't hear anything in the headphones. But it's coming back off tape now. So I think my bias setting is probably not bad where I've got it set now. It looks to be fairly balanced. Yes, I know this meter is sticky. I'll have to see if I can fix that and get that to unstick. I'm going to try putting a music source on here, and we'll see how this thing sounds actually recording music. And I'm just going to listen to it with my headphones. I'll play it through the speakers a bit. I'm just going to play some royalty-free music here, but I'm going to listen through headphones. I want to see how it sounds to my ears, switching between source and tape. I could hear a whistle through the speakers, and I couldn't figure out where the heck this noise was coming from. You can hear it now. It's actually from my audio generator. Listen. I had the patch cords to my audio generator just lying next to the patch cord for my amplifier, and I guess the signal from the audio generator was sufficient that we were getting a bit of crossover just from the patch cords lying on top of each other, which is really odd. Well, the generator itself is it's a balanced output, so basically there's signal on both the shield and these weren't grounded, right? So with the cord just lying there, this is acting as a radiator. I just wonder, what the heck? Why am I hearing this whistle in the background when I'm listening to the music? I didn't hear it through the headphones plugged into right into the deck itself, but I could hear it through the speakers. And then when I plugged my headphones into the speakers, I could hear it again. Now, what the heck's this noise? And I realized, wait a minute, that sounds like my audio generator. And I turned off the switch and it went away. And then I realized that I was getting some crossover. So anyway, I'm just testing this unit now. It's actually sounding excellent. I'm just going to drop the machine down to 3 3/4 now, which I have. This is playback from 3 3/4. And I'll drop it down to 1 7/8 and you'll hear the speed drop here. And you can also obviously hear the sound quality difference. The highs are all gone, right? Back to 3 3/4, you'll hear the highs come up a bit. And to 7 1/2. And my tape is ended. So let's rewind this and take a listen to how it sounds. But we were able to hear the playback anyway as I was making the recording. We were able to listen to it because it has live monitoring. The source will have to be in record mode, but source comes up there when you're in record. Sounds excellent. I think it's probably equalization for different types of tapes. I don't have the faceplate. I don't have the manual for this. Well, I have the manual. It's just in German. I can't really read it. So I'm going to put the shield back on the bottom of the board here because I think my adjustments are probably okay. And then we'll deal with that meter and see whether I can get something to work on that meter. See if I can get that thing to unstick. Now, quite often what causes a sticking meter is the needle is physically stuck. And sometimes you can pop these things apart if you just very, very carefully. They're usually just glued together with like a plastic type cement. So if you're very careful, you can quite often just pop these things apart. And see, this one here is coming apart quite easily here. And find what's causing it to stick. There it is. So more than likely what's causing this thing to stick is this back is come unglued, which it has, as you can see. I'm just going to glue this background back in place, and then we'll put the meter back together and see whether that solves the sticking problem of the meter. I just want to carefully clean the areas that I touched, and I don't want to use any type of cleaners or anything on this because I'm afraid that putting alcohol or something on here might damage the finish. Okay, now let's just try putting this meter back together, and we'll just pop it together and put some glue on it. Let that dry for a few minutes, and we'll reconnect it and see whether it looks a little better. It looks like it's going down where it's supposed to now, right down to the bottom there. Anyway, we got to clean those connectors at the back. connectors at the back here look like they could use some cleaning. Look at that. Just, you know what I'm thinking of using, right? I'm thinking of using this stuff where I can just wipe it on with a Q-tip and clean it. So here's all the crap that we're getting off this tarnish. These are actually silver, silver plated or solid silver. They're probably just silver plated, but anyway, they got a lot of tarnish on them, as you can see. This is what's coming off the outside of the jack itself. So I'm just putting some deoxit on here, and I'm actually using the polishing action of taking a cord and just plugging it in and working it in. And then wiping off the debris. But you got those contacts went from black to nice and shiny here, so I think that these are probably okay. And I've done the same. I put some deoxit actually inside here as well. So let's take a listen now, and I don't know whether I've got my left and rights reversed or not. It doesn't really matter. Let's take a listen to playback. Okay, we're going to do one last test recording and then send it on its way. That's source. And there's playback. Okay, that's it. Let's look at this Philips N4504 again. It was brought to me by one of my viewers, and she did a good job of cleaning up the board, recapping it, replacing all the belts. Everything's looking good on here. Just need a little bit of extra help with some test equipment to calibrate the speed and to get the bias set. And now this unit's sounding great. It'll give her many years of enjoyment. Thanks for watching, and we'll catch you again in another video real soon.